Hi, guys. We're going to go ahead and talk about the difference between confounding and lurking variables. So, what those are, and then the difference between those. Very commonly confused. Honestly, I've seen that wording changed up depending on if you're in psychology or whatever discipline you're doing some statistics in. Then I've seen them interchangeably use these words before, but technically they do mean something different. Okay, so let's talk about that. All right, so confounding variable is when uh, what you're measuring, so say if you're measuring the height of the tomato plant, is at least partially attributed to uncontrolled variables or something else that's in there. In other words, you can't tell which explanatory variable created that response. So you can't tell, there's too many variables. And so you haven't isolated it so you know what the cause is. Confounding almost occurs most commonly in a poorly designed experiment. Because if you designed it correctly, you want to control everything so that you don't have these confounding variables, so that you've isolated that one treatment. Okay, so let's look at an example. So here we have a situation where a child creates an experiment to see if a fertilizer produces better quality and better production results on his tomatoes. He tests the fertilizer by putting it on the plants that are in the sun. So here's the plants over here, they're in the sun. He puts the fertilizer on them. Okay. And then over here, these tomato plants, they do not have fertilizer. They're non fertilizer on those plants. And then what's happening is, though, these plants over here are in the shade. So this one has fertilizer and sun. This one, no fertilizer, but no shade. I mean, no sun either. Okay. So what happens is months later, the fertilized plant, the ones over here, had much better tomato and more tomatoes. Why? Well, we can't tell exactly why. Maybe it is the fertilizer. Okay, maybe the fertilizer made them do better. But you know what though? Maybe it's the sun. These had sun, those didn't. Okay, we're not sure. So we are unable to conclude that the fertilizer works because any effect that the fertilizer has is confounded with the effect of that extra sunshine. All right. So let's just kind of put in some things here. We talked about some of this vocabulary yesterday. What is the response that is being measured here in this story? What were they measuring? Well, I think they were measuring the production and the production and quality of the tomatoes. All right. What is the claimed cause or explanatory variable? So, what are they trying to demonstrate as the cause to that response? Well, he's trying to talk about this fertilizer and say that it did that. Okay. However, because it was poorly designed, we couldn't tell. It was confounded with and could have also been the sunlight. Okay. So let's talk about what's happening here. So we have this little situation. You know what? Let's do a different color, like this, like purple. Okay. So we have a situation where we had that plant production or the tomato production. Okay. All right. And so, but the thing was, okay, he was trying to attribute that increased plant production to the fertilizer. Okay. But it was a poorly designed experiment. And so there was a confounding variable, the sunlight. And so because of that, see this right here, you could not claim a cause. You could not say that, you were unsure of what was happening right here. Let me get to where I can draw on that. You didn't know if it was the sunlight or if it was the fertilizer. Okay, you were unsure. And so over here, I'll put the song in the notes and such for you, but here we have confounding variables song. And so, of course, it goes to 99 bottles, 99 variables in the experiment, 99 variables. Okay, so here's the key. Confounding variables cloud the issue. You can't claim a cause. So we had those two variables. We couldn't claim which one was the cause to the increased plant production. Okay. And then 98 variables in the experiment, 98 variables. Confounding variables cloud the issue. You can't claim a cause. All right, so you can go and listen to that if you want to. Down here, I just say, create your own example. So pause the video here, think about it for a second, and create your own video. And then I'll put what I have, an extra one I put. Okay, so say you're testing a type of wood stain. And so what happens is you put the new wood stain on pine wood, which is softer and more absorbent. You would put the old wood stain on oak, which is more dense, harder, not going to absorb the stain as much. Okay. And so as a result, whichever one gave you the quality you wanted, you couldn't tell the difference between the new and the old stain effectiveness, efficacy, because the type of stain, you don't know if it was the type of stain or if it was the type of wood. So the qualities of the wood that allowed the stain to work better on one thing than the other. Okay. Confounding variables cloud the issue. You can't claim a cause. All right. Now let's go to this one called lurking variables. Okay. So, and yes, and let's remember that with the confounding that we just finished, typically that is more prominent with an experiment, okay, where you are having treatments, but you didn't control what you were supposed to do. I mean, you didn't control all the other variables, okay? So then you couldn't claim that that treatment was the cause or if it was attributed to other things. All right. So, with lurking variables, let's take a look at what's happening here. There appears to be an association between two variables, okay? But the response is the result. So the result that you're having happens is because of some other third unseen variable happening. Okay, um, this this is common or something that you really need to watch out for with observational studies. Okay, it could also in surveys. Okay, so that's common there. So let's take a look at example to help you understand what that means. A study is done to collect data for the average number of TVs that a country has and the average life expectancy. Well, you'll see a clear association because the countries that have fewer TVs also have lower life expectancies. You have some third world countries, well, they don't have very many TVs there, and their people are not living very long. Okay. All right. So there's other things at play here. Other unforeseen things that aren't even in this story. Okay. That's the thing I want you to know. These lurking variables are things that I may not have even mentioned in this story. They are worldly things that I have to come up with on my own because of just kind of some common sense and just my knowledge of the world in general. Okay. So look here. the lurking variable is just that general economic well-being and standard of living. Okay, that probably explains both. Higher standard of living is going to have more, going to cause people to have more TVs. The higher standard of living is going to cause people to live longer, better health care, all those kinds of things. So you have something else that is tying those two together, making it look like they are related when they are not. Okay? We don't actually think that having a TV increases your lifespan. All right. Another common thing you need to watch out, another phrase you need to understand from this is that just because two things are correlated and related, and there, might be a relationship or association between them, correlation does not imply that there is a cause. So just because those are correlated doesn't mean one is causing the other. All right. So here's a song over here. Okay. And so let's kind of talk about it because it has a story. It is a story in itself explaining a lurking variable. Okay. So it might seem crazy what I'm about to say. There was a big fire last Saturday, hot coals and plumes of smoke everywhere. They sent a lot of firemen in there because there's a big fire. Lurking variables make it look like there's a link. That's a key phrase. Lurking variables made it look like there was a link. Well, all over the news about this and that, there was too much damage, huge amounts of damage in this fire. You can't go back. If you send a lot of firemen to help you, firemen will cause the damage. It's what they do. Firemen will cause the damage. It's what they do. So that's supposed to be facetious or sarcastic, okay? Obviously, so the link that's trying to be made is that firemen caused the damage at the fire. When you send more firemen, there is more damage, implying firemen are causing the damage. Okay, but that's not happening. There's a lurking variable making it look like there's a link when there is, some other thing tying it together. So let's take a look at that. So what response is it that they are measuring in this story? Okay. So they're talking about the amount of damage that has happened, that has occurred. Okay. Now, the silliness of it is that they're saying more firemen, more damage. So they're intending to say that the firemen, the, the number of firemen to the fire, okay, explains the amount of damage. Okay. All right. Positive correlation, more firemen, more damage. All right. But we know that there really is something else at play. Hasn't even been mentioned in this story. Okay. What do you think that is? Hopefully you can come up with size of the fire. And so let's look at this little diagram I have here. So what happens is, the story makes it sound like the firemen, do that a lighter color so it'll show up better. The story makes it sound like the firemen are causing the amount of damage. Okay. So that's what the implication is. Now, also, let me kind of remind you that this is an observational study. You would just take records of the number of firemen and how much damage there was and you could randomly select different fires and such. But here's, the deal is, it's not an experiment where you controlled and you randomly assigned a treatment. There wasn't a treatment. So this is an example of an observational study. Okay. But we said that the size of the fire is the true culprit that is influencing. And so then I'm going to get something to draw here. Let's see. Okay. So this size of the fire is influencing the number of firemen that come. This size of the fire is influencing the amount of damage. This is not a relationship to where the firemen are the ones causing the amount of damage. Okay. All right. So now come up with another example. These are kind of hard to think of, but you know what? Even when I was doing notes today, I kind of, with the students today, I kind of came up with another one. And so I might talk to you about that here in a second. But here we go. Creating an example of an observational study that has a lurking variable. Let's see what we can come up with. All right. Ah, this is interesting. Okay, I like this one. Because this is a true story. So this was an interesting thing to consider and to think about. Okay, so guess what happened? The students who attended my AP review sessions at the end of last year, during quarantine, made fours and fives on their AP statistics test. All right. Now, does that mean that the AP review sessions caused are what caused the students to make fours and fives? Okay. And I hope that you can, reason that that is, not necessarily. Okay. There is some other thing happening there. Do you know what that is? Well, let's think about it. Those students who are strong, caring, I guess I should say academically um, conscious, academically conscientious, maybe that's the word I should use, conscientious, students who are strong, academically conscientious, hard workers, they're strong just like in general, okay, were the students who put in extra effort. And in essence, really, it was all year long. It wasn't just attending the review session. Okay. So what's happening here, let me see if I can kind of come up here and reproduce this little picture. So here's what was happening. We had the, go back to what we had. Okay. So we had the AP review, the review sessions. And it appeared as though the review sessions were what made students have a high score. Okay. All right. But it helped. It was part of it. But is it maybe because those are strong students academically? So, truthfully, then what happened was these strong students, and they were very conscientious, go to the review sessions. These strong students who are conscientious have been working hard all year long. And what did got a high score? It was not purely caused by my review sessions. I wish I could say that, okay? And maybe I should say that to the administration and let them think that. But those who know statistics know that there are other variables here at play that made that connection. This lurking variable made it look like there was a link, okay? All right. So I think that was all of the notes between lurking and confounding. Hopefully that cleared it up. I'll attach the songs to this page so that you can also listen to those if you want to. They're kind of silly, especially the 99 variables in the experiment. That one's pretty crazy. Okay. All right. I hope that clears things up for you.